This particular webinar is going to be about designing universes and ranking systems. What is going to come up, the following webinar is going to be about designing simulations, and then principles of backtesting, and then strategy implementation. So the basic question is, when you're thinking about strategies, where do you want to put your rules? Do you want to put them in the universe? Do you want to put them in your ranking system, or do you want to put them in your screen or your simulation? And there's two different kinds of rules you could have hard and fast rules, like price is greater than $1, or market cap is greater than 50 million, or sector is not financial. And these hard and fast rules are probably better to put in universes rather than in screens or simulations. And I will explain why in a few minutes. Flexible rules are like, I don't want companies with huge accruals. I want to avoid companies that are losing tons of money. I want to screen out companies with high Benesch scores. They can be also, I want companies with low PE. I want companies with high growth. I want companies with solid margins. Those are all flexible rules that I think are better to put in ranking systems because if you put them as a hard and fast rule in a universe, then it's a kind of necessarily arbitrary limit. I guess with Benesch score, maybe not so much, but most of these limits are somewhat arbitrary. Ranking is more flexible. And again, I'm going to explain all this in more detail in a few minutes. With the universe design, you want to put as many hard and fast rules in your universe as possible rather than in your screen or your simulation. And the reason is that ranking systems will work more accurately on a delimited universe than on a large universe from which you subsequently exclude or remove stocks. Let's say the ranking systems work differently on delimited universes. So let's say you want to rank stocks on the core combination ranking system, and you want to exclude over-the-counter stocks and stocks with a market cap under $1 billion. This is our core combination ranking system here. It's one of our P123 ranking systems, and it combines 6 core ranking systems into one. So let's gonna do a little experiment. Let's rank all the whoops. Let's see, change settings. Let's rank all the no over-the-counter stocks first. And let's include some names, include composite ranks, and see what happens here. So we have the highest ranking stocks are Target, HP, Ternium, Dick's Sporting Goods, Williams Sonoma, Mercury General. Now, these are all over $1 billion, as you can see. Now let's rank only the stocks with market cap over $1 billion and exclude the others. So I'm going to change the universe to one that I designed myself, market cap over $1 billion, and we'll run it again. And we see quite different stocks. Here now we have Target is still number 1, but here we have Old Republic and Fidelity National Financial are number 2 and 3, then Buckle, and then Williams Sonoma, and then Mercury General. So these 3 stocks here started ranking very high when we excluded stocks with under $1 billion market cap. So why are the companies chosen so different here? And it's because of noise. If in addition to the stocks that you're considering buying, you rank a whole lot of stocks you have no intention of buying, you're introducing noise into your ranking. Ranking that only includes the stocks you want is going to be relatively clean. Ranking that includes a lot of stocks you don't want is going to be relatively messy. So excluding stocks that you don't want from stocks that are already ranked isn't a practical use of ranking. So let's say you had to choose a bunch of soccer players for the Chilean national team, and you decided to rank them by a variety of considerations. Would you also want to include Brazilian, Bolivian, Uruguayan, and Argentinian players and then discard those later? That's what ranking these extra stocks is like. You should slim your selection first. Now, another question is, why have any universe rules? Why not let the ranking systems do all the work? This is basically the way I've always been inclined, is to let the ranking system do all the work. But sometimes you just need to place limits. And the examples are minimum prices, minimum liquidity levels, and I'll talk about this in a few minutes. You might want to exclude stocks of certain groups. For example, you might want to exclude MLPs or REITs, or companies in certain industries, or companies in certain countries. You might want to exclude over-the-counter stocks. You might want to exclude ADRs. It all depends on your preferences. You might want to exclude stocks whose recent corporate actions will make their fundamentals irrelevant. Mergers is a good example of companies that are going through a merger process. You may not want to include. If you have a company that has just paid a huge special dividend, you might not want to include that company because its assets are going to be terribly misstated. You might want to exclude stocks with stale statements because their fundamentals are no longer completely current. There may be other hard and fast thresholds you don't want to ever cross. So I have a question here from Chris. He says, how do you adjust for small, mid, or large cap filters when the general market capitalization has risen over time? And I'm going to get to that in a couple slides. It's definitely part of my presentation today. Now, when you use hard and fast, you can use hard and fast rules in ranking systems. So instead of excluding all over-the-counter stocks or all ADRs, you could just make it a bit harder for them to rank highly by using a Boolean node in a ranking system. A Boolean node is, as you can see this by the illustration there, it's got a little 0/1. A Boolean node just means true or false. Whoops. And these Boolean nodes can be applied to any of the examples I just gave you. I have another question. How do you exclude stocks with stale prices? Well, I was excluding stocks with stale fundamentals, but I don't know of stocks with stale prices, really, unless what you could do, I guess, is you could use a rule that excludes stocks whose latest volume, the volume over the last day is 0. But what I really meant was stocks with stale statements, stale fundamentals. And that you use a command stales, STALE, STMT equals 0. That'll exclude stocks with stale statements. Now, remember, your fundamentals should be applicable. That means, some people argue that the fundamentals of biotechs, for example, are inapplicable. Some people would say the same thing about companies that have recent IPOs. Trustworthy. If a company is based in a country with lax safeguards, it might be lying. We saw that with China about 10 years ago. And recent. You don't want to rely on data that's years old. For some stocks, their most recent quarter might be a year old or more. So there are ways to write universe rules to exclude those kinds of stocks, because if your fundamentals aren't applicable, trustworthy, and recent, then ranking on those fundamentals may give you some results you don't really like. I have found over the years that the most practical way to find this kind of stuff is just to best is just to look at your screen, see what it gives you, look at the company and think, do I really want to invest in that? And if you say, God, no, then you might want to write a rule to exclude it. Now, liquidity constraints are a big deal, especially if you're interested in investing in microcaps, which are offer the most potential for returns. Price. Do you really want to buy stocks that are priced at 25 cents? I set a limit of 50 cents, but I have used limits of 75 cents and $1 before. It's not a bad idea to put some kind of limit about price. Volume, let's say 2 stocks move 1 million shares a day, and one has a price of $1 and one has a price of $100. Are they equally liquid? No. Instead of using just volume, use daily dollar volume, which is average daily total or median daily total to calculate volume. Market cap is, in my opinion, a poor proxy for liquidity, but some people like it because it's clean and simple. But you better watch out because you might have companies appearing and disappearing from your screens as they cross the market cap thresholds. Bid-ask spread, I find very useful. But remember, it's denominated in dollars, not percentage. So what you want to do is you use loop median or loop average and then divide by price, or divide by price first and then use loop median or loop average. Now, also be careful with bid-ask spread because we have no bid-ask spreads for over-the-counter stocks. So if you use a hard and fast spread limit and you don't allow for NAs, you'll be excluding all over-the-counter stocks, whether you like it or not, and Canadian stocks too. So just be careful with that one. Now, a limit of $100 million in today's dollars is going to be very different from a limit of $100 million in 2001 dollars. And this gets back to Chris's question. So for truly accurate back testing, it's best to use flexible restraints. And you can do this like this. There are 2 ways you can do this. First, you can denote your hard and fast limits as multiples of a stock market index or the CPI or the GDP. For example, a limit of $100 million today is a limit of 42,827 times the Russell 1000 index. And you can just look up what the Russell 1000 index is, and you can do the math. So instead of writing market cap is greater than 100, you could write market cap is greater than 0.042827 times $RUI. Or you could do something similar with close 0 hashtag CPI if you want to use the consumer price index. You could also use gross domestic product, gross national product, all sorts of other things that you can use to kind of peg your limits as over time. I prefer using indexes, but they do have the disadvantage that during severe market downturns, your limits are going to go zooming down. The same kind of rule applies if you have lower upper limits for daily dollar volume, sales, assets, or anything else denoted in dollars. Another option is to use F rank. For example, a limit of $100 million in market cap is the same as F rank market cap, all descending 30 is greater than 33 if you're using the all fundamentals universe as your starting point. Another similar thing is to use F order to get, say, the 4,000 biggest companies and just leave it at that. That's a really elegant and simple way to define your universe. And you could just use F rank for with market cap or with liquidity or whatever. So that way you're not confining your universe unrealistically. Why ranking system nodes are generally better than hard and fast rules. It's because every factor can be expressed in 2 ways, with hard and fast limits or with ranks, and you can therefore apply the same logic to all factors. So let's say I create a screen with hard and fast limits for wonderful stocks and a screen for terrible stocks, and I use different factors in each screen. Backtesting the first screen will give me terrific results. Backtesting the second gives me horrible results. But it's entirely possible for one stock to pass both screens. This can't happen with well-designed ranking systems because you can include every factor, both good and bad, in them. Screens, on the other hand, exclude a lot of stocks for each rule, so it's very hard to make a screen with more than 6 or 7 factors. Also, with hard rules, you might filter out an otherwise excellent stock just because it failed one rule by a small margin or had an NA value for one factor. Screen backtests with hard and fast limits and no ranking are, in my opinion, deeply flawed and may exhibit very low out-of-sample persistence. Now we'll get to ranking system design. There are 6 kinds of nodes we're going to talk about. Composite nodes, which are used for grouping related factors. Conditional nodes, which are used for factors whose behavior is different for different kinds of stocks. Boolean nodes, which are used for yes or no factors. Factor nodes, which are shorthand factors that are already in our system. Function nodes, which allow for a title and a formula. And industry nodes, which allow you to rank a stock based on its industry. The best place to start with ranking system design is to use Portfolio 123's core combination system and revise it. You want to save it to your own ranking systems first. So here's the core combination ranking system. I can save as, and that's fine, copy 3, no problem. And that way I can mess with it and do all sorts of things with it. Now, if you want to start with a basic library of functions, right now the core combination system is grouped into 6 groups, and all the functions are in these folders, right? Now, some people like to start with a basic library of functions and take everything out of folders and just have a long list, and then they can do what they want with them. The way to do that is to get rid of all the composite nodes by using the text editor. You can just say composite node, composite name, composite, delete that, and then delete this, and so on. I'm going to cancel this out because you have to do it well, but that's how to do it. And then once you do that, it'll take you 5 or 10 minutes, you'll have this long list of functions. Now, you can also keep them grouped. I'm going to talk a little bit about the difference in the way ranking works when things are grouped and are ungrouped. But if you have a lot of factors like this, it's not going to make a big difference whether you keep them grouped or not. I have seen very little difference between performance of grouped and ungrouped ranking systems with the same factors. The other thing you can do when you're revising core combination is you can delete nodes that you have no faith in. So, for example, let's take a look at core momentum, and let's look at price changes. Let's look at quarterly returns. In my opinion, 3 months % return, I think all of these are, not really worth keeping. They're not factors that I use, so I can just, I can change their weights, but I can also, hold on, I have to move these boxes around. I can also just take these and, go to node properties, and I can just cut. There we go. Now I'd have to reassign the weights here, otherwise, because they don't add up to 0, but I can do that by normalizing. I can put in a new node. Let's say I want to include in core momentum, let's say I want to use value weighted momentum. So I can put in a new node, stock formula, VMA, and I'll just use VMA 15 divided by VMA 230. Just random numbers here, but get the idea. And I add it, and now I have VMA here, and then I want to assign it some weight. So I like VMA, I'm gonna put it 30%, normalize. There we go, update. You can add a new composite node. Let's say, okay, I've got core momentum, quality value, all this stuff, but I don't have size. So I can go to core combination, add node, composite, and call it size. Oops, without cap locks. And there we go. And now I've got a new folder that I can fill with other nodes. So this is a really good way to get a start on creating ranking systems. But you could also start from scratch. You know, I've done that plenty of times. Now, let's go to composite nodes. These are essential if you want to tie two factors together. For example, if you want to rank stocks on yield, but you don't want stocks with high payout ratios, you should use a composite node with yield, higher better, and payout ratio, lower better. That's a really good example of things that you just really do want to tie that together. You don't want to, I mean, most stocks have no yield and no payout ratio, you know, but I think these are the kinds of things that you do want to tie together. There's a lot of factors, there are a lot of ratios that you find in reading financial literature that are incredibly complicated, that can be broken up into a two-node ranking system instead of all smashed together. For example, the PEG ratio, I find really odd because dividing PE by growth doesn't really make a lot of sense. You want stocks with high growth and low PE, fine. Just combine them as a single node in a ranking system. So it's also useful for grouping factors together, as I just showed you in the core combination. But just keep in mind that stocks will rank differently, whether the nodes are grouped in composite nodes or whether they appear in separate ungrouped nodes. So I'm going to give you an example of how stocks can be grouped differently. I'm going to go to a ranking system I created. Actually, let me just save this in case we come back to it. Ranking system I created, and it's called four-factor ranking system. Now, this has 5 groups here. I've taken 4 factors and I've grouped them in different ways. Here I've taken the 4 factors and grouped them like this. Operating income growth and market cap are in one group, and share turnover and volume increase are in another. Then I've grouped them differently. Operating income growth and volume increase are in one group, and volume shares out market cap are in a different one. And then I put them all in one group. So let's try that one first. The weights are all, it's all in one group. And I'm going to look at the ranks of 10 stocks. So my universe is going to be, 10 stock universe. And we'll run it. And we get Plumas Bancorp, the top ranked stock, then Cardiovascular Systems, then Paciro Biosciences. Okay, I just chose these 10 stocks at random, but this is how they're ranking right now if we use that. Now, let's say we group them all in group 1A and B. Update, save, ranks, change settings, rerun. Now, hold on a sec. I don't know if yeah. Okay, so now actually we still have pretty much the same order of the top 3. Now let's see what happens if we use the group 2 weightings. these boxes keep getting in my way. Update, save, ranks, change settings, run. Well, some reason it's not working the way it did yesterday. But anyway, trust me, the actual order does change from time to time, depending on how you rank these things. Sorry about that. Now, this is an extreme example, though, because I've only got 10 stocks and 4 factors. On the whole, it shouldn't make that much difference, but it does make some difference. And there is some material on our website that explains why it makes difference. It makes a difference to rank things in groups and separately. All right. Let's go to conditional nodes. Now, let's say you want to rank stocks on share turnover, lower better. This is a different example than it's on the spreadsheet, but I think it works a little better. I'm going to go to a ranking system I designed called share turnover. Now, this is a conditional node. Oops, you got to click on it to expand. Okay. Conditional nodes have this little diamond shape, right? And they have a true and false. Now, if you want to rank stocks on shared turnover, your highest ranking stocks are going to be ADRs and Canadian stocks, since the data you have is based on US exchanges. And that's not really what you want. Let's say you're including Canadian stocks and ADRs in your universe. You want to rank lower, better on share turnover. What's going to happen? Share turnover is the volume of shares traded divided by the volume of shares available. Now, most Canadian stocks are traded primarily on the Toronto Stock Exchange. Most ADRs are traded on stock exchanges all over the world. And the numbers you're going to get, though, because we're a US-based system, are going to be very small for volume. So all those stocks are going to rank right at the top. So a conditional node makes the most sense here. Either that, or you could just exclude those stocks from this, from this factor. But if share turnover is important to you, then you can use a conditional node. So what I've done here is I've used 2 nested conditional nodes. So this doesn't really make sense without seeing what the actual rule is here. This top rule is the stock in the ADR universe. So if that's true, I'm going to go to this. If it's false, I'm going to go to this. So if it's true, I'll go here. And if the stock is an ADR, I am going to rank it separately from all other stocks. So this is the average daily total compared to the market cap, which is another way of writing share turnover. And I'm going to compare that to all other ADRs and so ADRs will still rank but in a different order. I mean, they'll still rank, but they'll be ranked according to how they compare to other ADRs rather than how they compare to all stocks. And so I can do that here too. False, I have another condition here, and that's country Canada equals 1. So for Canadian stocks, I have the same rule, average daily total over market cap. And for US stocks, that's what's left over. They got false on ADR, false on Canada. I have a slightly different formula, average volume 252 divided by the loop average of current shares. So this is also a good way to handle enterprise value-based ratios. So if you want to rank stocks on EV to EBITDA, but you want financial stocks to be ranked on PE instead, which I definitely suggest, you would use a conditional node like this. Your condition would be something like, instead of universe ADR equals 1, it would be sector equals financial. And then if that was true, you'd put in PE. And if it's false, you put in EV to EBITDA. Now, we'll talk about Boolean function and factor nodes. Boolean nodes are useful for true-false ranking, and I showed you an example of that earlier. For example, if you want to rank over-the-counter stocks lower than other stocks, a Boolean node is a good way to go. Factor nodes are useful if you just want to use a factor directly from the reference menu. I'll go back to the core combination system and show you the difference. So this is a factor node. It just, all it consists of is the P123 formula for that factor. This is a function node. And you will see that it has a complicated formula in it and so on. Now you can also just create, I just treat everything as function nodes rather than, I don't use factor nodes just so that I can put my own title on it and I don't have to try and read a bunch of letters that don't necessarily make a whole lot of sense right away. So those are three useful kinds of nodes, and let's talk about ranking so that middling numbers are best. Now, this is something I went over in the last. I have a question first. This is from Tony Willingham. Is it practical to use conditional nodes to combine completely different ranking systems into one? For example, a ranking system for banks and another for REITs. I think it could be. I haven't tried that myself, but I don't see why not. And that's if you want everything to be ranked at once. Now, ranking so that middling numbers are best. Let's talk about method one using a parabolic function. I'm going to create a new ranking system, and it is, I have to give it a name. Let's just call it sales growth, and save. And it's just going to have one factor, sales growth, TTM, add. Okay. Now I'm going to run the performance. Whoops, I got to save it first. Now let's run a performance test. Let's do 10 years and let's use the no over-the-counter universe here. And 10 buckets. I'll run it. And we get a chart that looks like this. So it looks like we really want to rank these middling numbers the best, right? So what we can do is we can download this, open it with Excel, right? And we get something that looks like this. I hope that everyone can see this. It may be kind of tiny. Now I'm going to, so these numbers here that says 0 to 10%, 10 to 20, and so on, I'm just going to fill them in by the midpoint. So 5, 15, 25, 35, and so on. All right, now what I'll do is I'll copy these numbers and transpose them, and I will create a chart. Scatter plot. There we go. So now we've got the same thing that we just saw, except it's a nice scatter plot chart. And I'm going to get a trend line here and a polynomial trend line there. And I'm going to display the equation on the chart. There we go. So now we see that the equation for this result is negative 0.055x squared plus 0.5981x minus 0.1159. Now we can just take this equation and plug it in to our ranking system. So we'll just take sales growth. Let's just add a different node. Stock formula, sales growth parabola, and we'll do 0.0059 times F rank sales GR percent TTM and we'll square that. And then we'll add, what was the other one? 0.5981, 0.5981 times this thing again, except not squared. Add and weights 100, update, save. So now let's look at the performance. I'll run it. Ah, damn it. What happened? I don't need the constant. Chris asked if I forgot the constant. I don't need the constant because because ranking, you don't really need the constant. I don't know. It seems that this, I'm not changing the settings. Hold on. Why is it not working here? It's just, it's not changing anything. It's just giving me what I had. It's not refreshing. For some reason, the performance is not refreshing the way it should be. It's just giving me exactly the same chart as I had before. Well, this actually does work. Yeah, I guess I should just copy this node and put in a new ranking system and see what happens. Oh, I think I know what happened. Ah, I know what happened. Silly me. I forgot the negative sign. There we go. Now it should work. Sorry about this. There we go. So that's how the parabola thing can work. That's a pretty complicated way to do it. Now there's other ways to do it that are slightly different and slightly easier. The second way is to measure the absolute value of the difference between what you want and what you have and use lower, better rankings. So for example, here, instead of this complicated formula, I could have written something like this. absolute value of F franc. Let me just copy this. Minus, let's say 40. No, let's minus 60 because in this chart, the highest ranked one was this one around here. Oh, yeah, maybe 45, 55, something like that. And then we would just do lower values better. So this basically takes the difference between the rank and the number 55. Oh, Fabio wants me to explain a little better what I did with the parabola formula. Okay, so what I did here is I have this, the formula here is for this curve here that I generated by using the ranking data for all the deciles, right? What my original chart showed was that stocks that ranked very low on sales growth and stocks that ranked very high on sales growth did not have good returns. Stocks that ranked middling sales growth had the best returns. So I want to design a function that represents that. So I designed this. So I just took the data and I created a parabola out of it, a parabola line. And so the stocks that are going to be at the very top of the parabola are the ones I want to buy. And the stocks that are going to be at the bottom of the parabola are the ones I don't. And so I just took this formula and I used F rank because that's what these numbers are. The numbers on the x-axis are the ranks. And I plugged it into the ranking system instead of using just plain old sales growth. Now what I'm doing is I'm going to use the absolute value of the difference between the F rank and the number 55, or I could use the number 45 or whatever. And, just something that's around the middle, and I can rank my stocks that way, and it should come up with another nice ranking system. It's a little weirder, but you can change the difference number the way you want. Now, a third way to do it is we look at these numbers. These numbers here are all very similar, right? So what I could do is I could write a rule that says, okay, if the rank is between 20 and 60, I want it. If it's between 60 and 90, I want it, but not as much. If it's close to 100 or close or under 20, then it's garbage. So you can do that with using with an evaluation formula, so using the eval command. All right. So we'll say eval, and then we'll use the F rank. Eval F rank. And actually, I'm going to use a between command, between F rank. And then I'll put, what were the numbers? 20 to 60. 20, 60. Then it'll be ranked 3. Let's put it. And if not, it'll get 0. And then we'll do eval, and we'll copy this. We'll just copy this whole thing. But this time, instead of between 20 and 60, I'll say between 60 and 90. 60 and 90. And I will give those the number 2. And then I can do that again for the stocks that are under 20 or above 90 and give those the value 1. And then, so every stock will be classified where where it belongs in the F rank. And if it's between 20 and 60, it'll get 3 points. If it's between 60 and 90, it'll get 2 points. If it's between 90 and 100 or 0 to 20, it'll only get 1 point. And then I'll go with higher values better, and I will get another nice chart, I hope. So those are the ways to deal with ranking so that middling numbers are best. Now, industry nodes. Questions here are, there are a lot of things you can do with industry nodes. You can ask if the industry exhibits strong momentum. Does it have a strong or weak growth rate? Does it exhibit high or low share turnover? I even wrote a factor that assigns points to different industries depending on how well they have responded to my other factors historically. So I'm going to show you a couple of those. You can do the same kind of thing with sectors. Let's go back to the core combination. In momentum, I believe we have an industry momentum. There we go. So these are industry nodes. If you are designing an industry node with a factor that we already have in our system, you could just use that and choose rank industry versus other industries. So let's say I wanted to add another similar node. You choose an industry formula or industry factor, or you can choose an industry formula. And you can also, use a regular stock factor, always use the universe rule, but then just write, say, an aggregate rule here in the formula, aggregate with industry or aggregate with sector. I'm going to show you this formula that I wrote that does sector ranks, does industry group ranks, just to show you what the kind of weird, crazy stuff that I sometimes do when I have too much time on my hands. Let's see, it's this one here. So this one evaluates everything. I pasted the entire thing here so you could see it. So it evaluates all stocks and by their classification. So if it's in the ARBIX group 3515 or 3520, it gets 20 points. If it's in the ARBIX group 4515, 5020, or 5025, it gets 16 points, and so on. And I did this after testing all these different groups and seeing which worked best for my own particular ranking system. So now I know, so these stocks that are in retail and in semiconductors and in utilities get very low rankings because I don't really want to invest very much in those particular groups of stocks. They don't really work very well for my rankings. The stocks that work best are the healthcare, some of the materials and tech stocks. So that's the kind of thing that you can do, and then I can use this in a ranking node. But I would only do that if you really have too much time on your hands. Text editing. Now, I showed you this a little bit when we started out with the core ranking system, how to remove factors from conditional nodes and simply make them regular nodes. You basically take you basically go to the text editor of a ranking system. You get this enormous thing. Now, I'll just tell you that these tabs don't really matter. What I like to do is I like to edit these in Notepad++, or you can edit them in Word, or you can just edit them right here. But I use Notepad++, and it's very easy to just highlight everything that starts with the word composite or the word \composite and just get rid of all those lines, and you got rid of all your composite nodes. there are other things you can do too. You can delete 50 factors at once. You can add 10 factors from one ranking system to another system by just copying the text of those factors and then pasting them into another ranking system. So there are a lot of things you can do here. It's a really handy tool to make your life more complicated. Lastly, I want to talk about ranking methods. Percentile NA is negative and percentile NA is neutral. The NAs negative are best if you have companies like PE, where you want NAs, companies with negative earnings, at the bottom of the list. Percentile NAs neutral are best if you don't want to penalize companies with NAs. With this method, NAs rank in the middle. And remember that the ranking method applies to all nodes in the ranking system. You can't have a ranking system in which some nodes are ranked negative, NAs negative, and some nodes are ranked NAs neutral. This choice is very, very important. I feel that when you're using multi-factor ranking systems, you're going to get lots of NAs. And you also sometimes make mistakes. I mean, for example, I just made a big mistake when I was ranking things on size using number analysts Q. I didn't realize that stocks with no analysts at all were NA. I thought they were 0. And so I was ranking all the stocks that I really wanted in the middle instead of at the bottom. So there's that, or instead of at the top. So those kinds of things are important. So remember that it's good to choose the ranking method before you design the various factor nodes, because if you don't want to penalize NAs, then you don't want to use PE. Instead, you want to use earnings yield. You want to use a different formula. The other thing to consider is that if you change, this is something that we may have to change here at Portfolio 123, but right now the way it works, if you switch the arrow here, core combination, to lower values in order to get short, in order to get shorts, you want to short stocks. You want to choose stocks with really low rankings, but you want to design a ranking system. You want to use this in a simulation. So you have a reverse core combination, right? What this is going to do is it's going to give all the NAs right at the top. If you don't want the and that's if you are using the percentile NAs negative. So if you don't want that, you better choose neutral, or the other option is to keep the arrow the way it was and just change all the individual arrows of all the other nodes in here by just clicking each one and changing the arrow direction. So that's another thing to keep in mind when you are deciding ranking methods. All right, great. Well, I'll see you next at the next webinar in 2 weeks. Take care.